Okay, so let's get started with our our drone SDK Showdown. There are four of them that we're going to look at. The first three are pretty obvious. So there's the SDKs that come with DJI, the SDKs that come with Parrot, with Autel, and then we'll look at kind of the Pixhawk infrastructure ecosystem. There's quite a lot going on there. That's more of like the open source world. So there's a lot going on. We won't talk about Skydio as they don't have an SDK, though they don't currently have one. Hopefully they'll have one in the future sometime. But for the moment, we can't do anything with we can't create our mobile apps that will work with Skydio because we don't have an SDK. And the reason that we can do it with the other manufacturers' machines are that pretty early on they decided that they would use a phone as the video screens. So instead of having their own video screen integrated with the remote controller, they would just use the very capable screens that come with most people's mobile phones. And that's our in because we're basically creating our own version of the manufacturer's app for our own reasons, for our own workflows, and because we have an SDK, it means that they've basically given us a headless control library so that we can write our own UI, UX on top of it and write whatever kind of apps we want to do. So if we want to have one for a fleet management app, if we want to have one for for counting cattle, for if we want to have something for flying over a roof, because we have each of these SDKs, we can basically create anything that our imagination will allow us to get away with, assuming that the drone will support it. Pixhawk's kind of like I said, it's a different beast here because within Pixhawk, there's as many different branches, routes that you can go for all the different companies. So there's a RG Pilot, there is PX4 open source. There's also Auterion, there's Q Ground Control. If you want to control, that's the GCS, which is our ground control system. So everything has got lots of TLAs. So our GCS is basically what we're talking about designing today. We're not really talking about much else and how we'd use each of the different SDKs to do that. But like I said, Pixhawk has a lot of going on, and really I can't wait to do the deep dive in that in a couple of months so that we can talk about all the many different flavors. Okay, so without further ado, let's talk about DJI. So you can write a mobile app that will work with a DJI drone in Objective-C or Swift for iPhone or an iPad, and you can write it in Java and Kotlin for Android phones. There's also a Windows SDK, so a lot of the early GCS's ground control systems were written for laptops, so they work with a Windows, like a rugged tablet, that kind of thing. A Panasonic Toughbook is what springs to mind. And they would be .NET Windows apps, so you basically have them in C#. So DJI has that, and Pixhawk are probably the only ones that you can write the code to get it to work for Windows. So let's talk about, I'm going to have this kind of format for each of the different SDKs. So we got the prerequisites. We'll have a little hello world. For most of them, we kind of have two hello worlds. And then we'll talk about the different SDKs and then some resources so you can go and explore this yourself if you want to create your own apps. If you fly a drone and you also happen to be a programmer, I think it's a really good idea to look at how we could, take the step of opening up Android Studio or Xcode and then having our own little neat app to allow us to fly our drones. I'll talk a little bit, especially on DJI, about deploying and then some of the lessons learned over the last few years. So you're going to need to register for a DJI developer account. Up till recently, there were two tiers, one free, one $99. Now there's just one tier, which is free, which is great. The easiest way to get started is you could buy a DJI Mini or a DJI Mini 2. A DJI Mini 2 is $450, but you can get DJI Minis for $250 on eBay. You can do it with a Spark too as well, so even cheaper you could use the Spark. But if you want to use a lot of the functionality like mission planning and automated flights, then the cheapest drone you should use is really a Mavic Pro, which is probably about $1,000 now on eBay. You can't get a Mavic Pro or a Mavic Pro 2 brand new anymore. There's a Mavic 3, but don't buy a Mavic 3 hoping that you can program it, because the SDK doesn't support it yet. There's always a lag between when a new machine comes out and then when the SDK supports it. So it's probably going to be 6 months or so before that happens. Okay, so register for your DJI developer account. Create an app for yourself, so you can get an app key from DJI. And then you're going to need a drone to program it, and then choose your favorite IDE, so that it's Android Studio, Xcode, or even the Visual Studio if you're doing the Windows version. So like I said, you need an app key from the developer account, and this key goes into the Android manifest.xml file if you're working with Android. Most of this is going to be Android related tonight. I'm not really going to talk about iOS because I'm more of an Android dev. Okay, so we have an app key, and then you would basically take that and put it into your Android manifest file. I'll show you what that looks like in a second. So once we have our key, basically what we'll do is we're going to work with the mobile app, with the sample app from the github.com. So the DJI's SDK username is DJI-SDK. So we're just going to do a git clone, open the sample code in Android Studio, change the app key. Well, just enter the app key into Android Manifest. We'll talk a little bit about what we need to do to change the build.gradle file and connect the phone to your... If you're using Spark, you use Wi-Fi, and if you're using a different drone, we'll talk about how you do that. And then you just push your APK to the phone. The Android emulator isn't going to be much good to you because you actually do need to be talking to the drone. There is a simulator that you can use. So a lot of times what our developers won't fly the drone till quite close to the very end. You always have to fly the drone just to get a sanity test, but you can do a lot with the DJI simulator, and we'll talk about that too as well in a bit. Okay, so here's the Android manifest file. You can see right here that we need to put our API key in here, so we'll put in our API key, and it should have the same name as whatever you've called it in on the DJI website, in the developer.dji.com. So I don't know if it's still the case, but the last time I did this, I had real problems trying to get it to build because the ProGuard settings, which are shrink resources and minify enabled, were set to true. That seemed to mess everything up for me. I think that was kind of a conflict with Android Studio was going too fast, and they hadn't tested in the latest Android Studios. So Android Studio is still going lightningly fast. So if you find an issue compiling the code and you're getting a lot of errors, what you probably should do is just turn off the obfuscation. So set the shrink resources and minify enabled to false, and then it should build for you. Not really sure why you would want to have your the sample app obfuscated. So really, it doesn't really matter if you change these. Most times when you're doing this, you don't really obfuscate it till you productionize it, till you put it out on Google Play. So I'm not going to worry about it not being obfuscated. For those who don't know about obfuscation, basically what you can reverse engineer an Android APK back into Java source code. And what obfuscation does is it basically takes away a lot of the information, so you can't read the code anymore. The only thing that's missing when you reverse engineer an Android APK that is not obfuscated is you don't get the comments, but you get everything else. All the Java code is there. Obfuscation, ProGuard in particular is the tool that we're using. Makes it a bit harder to understand what's going on. We've kind of moved away a little bit from that because most people will write their Android apps in Kotlin, and the decompilers, which reverse engineer your APK, just reverse engineer it into Java. So it's already not really the original source code. Anyway, that's a whole different subject, meetup, etc. Okay, so we've compiled our hello world. We're going to connect our Phantom 4 or our Mavic. We turn on our remote controller, turn on the aircraft, and wait until the remote controller is connected with the aircraft. If you've flown it, you know the double tap you need to do to get both going. So you connect your phone to the remote controller using a lightning cable or USB, and then run the sample app on the mobile device. Can't remember off the top of my head if you need to turn the developer options on, but if you've never done it before, on an Android phone, just go to Settings and About Phone, and then click on the build 5 times. It's very 007. But anyway, that's what you do. You click on the build 5 times, and then the build number, and then that turns on the developer options, and then you can say that you want your phone to be USB debuggable, and that will allow you to be able to do this sort of thing. Okay. You'll get a message like this saying, opening the DJI sample, is that okay? Yes, it is okay, because basically what we're doing is we're debugging our app on our Android phone. And then when it opens, basically you get this. So sample app is way more complicated than it looks here. So when you open it, you can see all the different things that you could do. So there's lots about new interfaces. There's Flight Hub, where you can upload the images to the third-party cloud server. There's all sorts of things in here. Payload. So yeah, it's cool. Well, you can do payloads now. We'll talk about it with the SDKs in just a couple of minutes. But all that I did here was that I just went to virtual sticks, and then virtual sticks are you fly with these 2 black dots here. So instead of having your remote controller, you're using the virtual sticks here to fly. So you can take off. So be very careful what you're doing. Make sure that you have a GPS signal. Make sure that nobody's in the way. You know, it's have lots of space, because it's going to fly. So it's going to take off to about 3 or 4 feet. It's going to crash into things if anything's in the way. So this hello world will be your first time actually flying your drone using your virtual sticks. The remote control would still control it, so if the worst comes to the worst, you can still go back to it and hit return to home. But you just want to make sure that you're not treating this lightly. And then when you here, what I've done is it's live streaming, so this was just taken in the office, and then we can start a live show. We can turn the sound on and off. We can do all sorts of things. I'm assuming the live show is some sort of a RTMP live streaming. And then as you can see lots of different things. So you could spend a lot of time going through all the different things that you could do. And of course, the best thing with this is that the code is available. The only thing I would say is the code's in Java, which kind of is a pain. So last year we got some interns to convert the code to Kotlin. So I'm gradually releasing all the code over the next few weeks, coming up to AUVSI. And then next month we'll be doing a deep dive into the DJI mobile SDK, and I will have all of the examples released by then. So we'll be going through them one by one. And then the month after that, we'll do the iOS ones, because the iOS ones are in Objective-C, and the whole world has moved to Swift, so we converted those 2 as well. Okay, a little bit more. So let's define the ecosystem. So here are the DJI SDKs. There's actually one missing. So we have a UX SDK, we have a mobile SDK. So both of those are basically what you use. So the mobile SDK is all the functionality for the telemetry, for the camera, for the automatic missions, for everything, the log files. Actually, it's not the log files. I don't think you do get the log files. But it's basically everything that you need to fly a drone. And then the UX SDK, that gives you all the icons, so you don't have to get your designer to create everything from scratch. There is actually a UX SDK open source, so I think it's called the UX Beta. That's also out on GitHub. Go check it out. A lot of information there. All right, what else do we have? So the Windows SDK is for the desktop Windows app. The Payload SDK, that's really made me very excited, because the Payload SDK used to be really hard to actually get any information about the Payload SDK. So if you wanted to create your own payload, which could be anything, so we're doing one at the moment just for a simple light, for an LED light to turn on and off from your mobile app. So we'll have a mobile app that flies a drone, and then we'll also be able to turn a light on and off. But if you wanted to have a methane sensor or a Geiger counter or something, You now have the ability to connect that and plug it into the M210 and the M300, which I think is just amazing. I think the whole custom DJI drone abilities that gives us for the Payload SDK are just great. And then it was just before the new year, just before the holidays, that Payload SDK was made public. Before that, you had to tell them what you were going to do and then hope and pray that they'd be interested in doing it, which is probably from a marketing perspective. And I just want to do stuff. And the less barriers to entry, the better. So now the Payload SDK lets me do lots. I'm very happy. Okay. We have the onboard SDK too, and I've used that in the past. It's you buy a manifold computer, which DJI used to sell. I don't think they sell them anymore. There was 1 and 2. They've been end-of-lifed. And then essentially what you do is you plug that into the drone brains, and you can send it Python commands to do machine learning, all sorts of wonderful stuff. I haven't used it much. Mostly what we do, even for the machine learning, we'll basically do it on the phone. Pixel 5 is a phenomenal Pixel 6, an even better machine. They can do TensorFlow Lite. They can do object detection pretty rapidly, so we'll do a lot of that. The onboard SDK would be useful if you're kind of in a area that doesn't have a lot of internet connection. I could see that as being useful, or if you've got a lot of things that you want to do. So like a lot of edge computing capabilities there if you want to use the onboard SDK. Just tightening it down to what we're doing. So what can you do? So flight, advanced flight control, all the aircraft state data, the camera, move the camera around where you want to, get a live video feed, get access to the media on the camera. And with the live video feed, that's important to us sometimes because we want to chop that up into images so we can present that to our TensorFlow Lite library so that we can do our object detection and draw little borders around people or cows or sheep or whatever, or weeds that we're trying to detect. Missions, are you trying to do a mission? So are you trying to have an automated flight over field? Do we need to find information from a remote controller? And then obviously batteries, we need to know how much power we have left in our batteries. So we want to make sure that we're taking care of that. And the SDK will give you all that, and the Windows SDK too. And then the UX, is, like I said, just makes it look so much prettier. So like this is, if you look at this is obviously not using the UX SDK. UX SDK basically makes it look like it's the DJI app. Here is the simulator. So if you download the DJI system, there are different ones for different drones. This one's for a Phantom 4. So there's one for an M300. There's one for Mavics. So one of the best ways to test your drone is to use the DJI Assistant, which you can download from from DJI.com. So one of the tabs, as you can see here, is the simulator, where you connect your computer to the drone that's already ready to fly, and then you fly the app in the simulator, and it just makes it much easier to test. Sooner or later, you're going to have to test it in the real world, but it's a really good tool for not having to keep on going out all the time, especially when there's 6 inches of snow outside like there is tonight. A lot of people would have used the DJI Assistant for updating or downgrading their firmware. I think that's where people are introduced to it in the first place. So the simulator here is not to be confused with the DJI Flight Simulator. So the Flight Simulator allows you to connect your remote controller to a Windows laptop and basically fly. It's a great way to learn how to fly drones, so you don't want to be flying an Inspire 2 here without having a lot of practice. So the Flight Simulator is a really good way for you to get used to the controls before you take it out into the real world. So not to be confused with the DJI Assistant Simulator, which is what the developers use. There are also bridge apps, so you can use those for debugging to get lots of information. If you are on iOS, the iOS Bridge app was out for a long time. It's a really good way to debug over Wi-Fi. So I think there's an Android one now, although I haven't used it personally myself. When you're deploying, one of the things that you want to really think about on the Apple side is to deploy early and often. We always want to do an MVP as quick as possible, get it out there. I firmly believe that it's much easier to get an app in the App Store updated than it is to get the first initial one released. It just seems to go through a lot more review steps when you're pushing it out the first time. The other thing you want to make sure as well is you want to make sure that it's a two-stage process for a DJI app on the App Store. You have to get the MFI application approved too as well, which is the made for iPhone. So the fact that you're using a lightning cable with your Apple app, with your iOS app, means that you have to get not only the app approved, you also have to get the MFI approved. And you can get that approved through the DJI store, but you do not want to be doing this the day before you're supposed to be getting it released. So make sure you do it, in the second or third sprint of whatever you're doing. Also, the SDKs are huge. So the Android SDK, the mobile SDK, and the UX SDK, you're already going to be hitting the 100 megabit limit. So you're going to have a multi-dex app. Not too sure how that fits in with the AABs now, but in the old APK world, we regularly went over the size of the app, and then that could cause all sorts of problems. If you have issues with that, the GitHub issues list for DJI is a really good place to see how other people have solved it in the past. That's a great place if you have questions. It seems to be the most rapid way of getting an answer from the developers, the DJI developers. Don't wait until the last minute to get your app key too as well. So a couple of times we wanted to deploy something and couldn't get the key. Websites down. A few months back, iOS developers were out of luck as Apple stopped granting MFIs for DJI apps. Went on for about 6 months. Looks like that's been resolved now. I don't see that message there anymore. So for a long time, it was Android only. Unless you already had an iOS app key that you could use, then you were okay, but you couldn't get a new one. Next steps, well, here's some URLs. So developer.dji.com, the DJI SDK user under GitHub, tons of information, the Android SDK, the iOS SDK, the UX, the Windows SDK, lots of examples. If you look at the Reese.com blog, we have some examples as well, which would be in Objectives, which would be in Swift and Kotlin, and not in the original Objective-C and Java. It's worth looking at the forums, so see what other developers are doing. But if you have a problem, my advice would be to open an issue on GitHub, on the GitHub repo of your choice. It seems to be the best way to get an answer. Or you could try ask a question on the community forum. Okay. Like I said, next month we're going to do DJI Android, and go through all of the tutorial examples, but in Kotlin, not in Java. All right, so the Parrot and Afi Ground SDK is a good alternative to the DJI Mobile SDK. It has a lot of similar functionality, but for controlling Parrot and Afis instead of DJI drones. Talk again here about the prerequisites. We have a couple of hello worlds. There's also a large ecosystem for Parrot, and then some resources as well. So if you want to do this, you basically want an Anafi 4K. So there's lots of different drones. We have an Anafi 4K. We have the new Anafi AI, which is about 4,000. So it's quite a large barrier to entry. The Mavic 3, I think, is about 3,000. Don't quote me on that, but that's so the newer drones that are coming out are really expensive. And remember, I said the Mavic 3 isn't supported by the SDK yet, so you're gonna have to wait 6 months at least. There was so much trouble about the Mavic Air 2S, about people saying that wasn't supported. People were really disappointed. But as of December 31st last year, it's now supported. If you're just trying out and you just want to get your feet wet and see how the Parrots work, then you can get an Afi 4K for, can't buy them new anymore, on Best Buy or Amazon. So you're probably talking about $250, maybe a little bit more on eBay. Take your chances to see if it works or not. The thermal's going to be a good $500 or $600 more on top of that. There's a website called Woot, WOOT.com. They were running a special on Anafi 4Ks a couple of months ago, probably about 6 months now, and they were selling them for $100. We picked up 4 at that time. But yeah, you got to look around to find the 4Ks. We don't need any API keys. We basically need to download and install Android Studio or Xcode and create a new Kotlin project, and away you go. The SDK we're using is called Ground SDK, and the The environment setup only lists Linux or Mac OS, so Windows users are out of luck in this case. So what we do, git clone, ground SDK, Android samples. There's 5 or 6 in there. Open the Hello Drone directory in Android Studio on a Mac. Connect your phone to the Anafi 4K and then push the APK. And then it's been a while since I've done this, but this is the one this is basically what it looks like. Huge amount of stuff going on, just like the DJI sample app. So they're not really hello worlds, but I've done a hello world, so I'll talk about that in a second. Also, the Parrot. So the Parrot Anafi is a good alternative. Ground SDK is a good alternative to the DJI mobile SDK. Same things you'd expect, telemetry data, controlling the flight, getting the video stream, all that sort of stuff. One of the things that when we first looked at it, when we were really trying to start out with Parrot, we thought that the example app was really complicated. So we did a much simpler one. So if you want to go and check out our Parrot app, you'll see it has the virtual sticks that were on the DJI example. So these basically, they fly the drone. And there's 2 activities that we have, 2 Kotlin activities. So you can just check it out. One connects and one flies. Really, really basic. So we use that for some of our interns so that they can get up to speed quickly and figure out how to connect to the drone, how to make it fly. And then after that, you can go into the Parrot example, which has lots more going on. Okay. Here are all the different drones. So we've got the Anafi 4K, so that's the $100 one that we talked about from woot.com, probably $250 on eBay. The Anafi Thermal, I'd expect to pay at least $500, if not $1,000 more for that. The Anafi USA, so that is a version of the Anafi 4K and Thermal combined, so it has them both together. I think it has 3 cameras. It's, as the name would suggest, is for military and first responders. So if you're listening to this outside of the US, I don't know what the availability is, but it's, like I said, it's really for police and for the military. The other one is the new one is the Anafi AI, which just looks amazing to me. I think it's absolutely beautiful. Very, very different design. It's supposed to look like a mantis. Looks really cool. So that's kind of the top of the range, and that's 4,000. You can see some Bonjour there, so obviously they're a French manufacturer. Okay, so here are all the different SDKs that you need to know about. So we have the Air SDK, which works with the new Anafi AI, the Ground SDK, which we just talked about, which works with the Android Anafi. We also have an open source. The app that you use to fly the Parrots is called FreeFlight, the manufacturer's app. So there's an open source one called OpenFlight, only available on iOS, but it has all the code. Sphinx is the simulated environment. And then there's also an Olymp, which is basically if you want to write Python scripts to control the drone. So instead of you flying with, it's almost like a command line tool to get you to fly the drone. So it's but I don't really use it that much because most of the code that we're writing we'd have to throw away if it's in Python. We want to write our code in Kotlin or in Swift. What else do we have here? And the simulation tool is just out of control now. Is out of this world now. I'm going to show that in a bit. The Parrot Sphinx relies on the Gazebo and Unreal Engine. So Gazebo is like a pretty early simulator that people were using. Looked a bit like the DJI simulator, but it's now combined with the Unreal Engine. It's really cool. There's another library called Pdraw, which is a pretty low-level OpenGL tool for writing on top of whatever the screen is. So instead of you using icons, you can take data from a third-party API, put it into your app, and then use Pdraw to write on top of it. Okay, let's have a look at this now. This is the Sphinx. I'm just going to play this. Speed it up a bit. So you can see that oops, that was not what I wanted. you just see that the fidelity on this is just amazing. So I'm hoping that there may be a way to use this for creating environments to be able to train our machine learning, do object detection, that sort of stuff. It's obviously streets ahead of where we were with the DJI simulator. You can see here there's like 3 different types of cameras, black and white. Assuming this one's supposed to be thermal. A lot of work seems to be lately about creating digital twins for cell phone towers. So I can see what's going on here. Basically, getting the map, and then you'd have a larger 20 grand drone that would come later that would have a much better camera and get much better fidelity again. Okay, so that's Sphinx. That's probably going to be a lot of what I'm going to be doing when we talk about when we do the Parrot deep dive in a couple of months. Okay, so what do you want to look at? Well, then there's developer.parrot.com. That's where you go. That's where everything you'll get, passed off to the GitHub repo, Parrot developers, Ground SDK. We have the example where we have the Parrot example is there too as well. And there is a forum, so there's quite a good forum for Parrot developers. So there's a lot of people asking questions there, and usually get an answer about 24 hours. So on DJI, I would say it's the GitHub repo, but for Parrot, it's the forum.developer.parrot.com. Okay, so Autel. DJI probably has 85% of the consumer market, and then Parrot would be, an Autel would probably be 5% each, is what my guess is. I think that's what I saw before. I may be out by 5 or 10%, but that's probably about it. So Autel is the prerequisites: Hello World, 2 again, SDK ecosystem. About 6 months, same thing happened to Autel. Everything changed. They brought out a ton of new drones. I'm really just talking about the Autel Evo 2 because that's what we played with most so far. And then again, we'll have some resources so that you can look at. So you have to register for an Autel developer account. So you need to get an app key from the developer account to be able to create your app. Back in the day, you basically would fill this in and then hope that you get an answer. It's actually working now. People are coming back. We got an API key for our cattle counter app, which I was very happy about. So we did that with the Evo. And then, you're going to do your coding in Android Studio or Xcode. So if you need an app key, you go to pro.autelrobotics.com, or if you can't remember that, you go to the autelrobotics.com and then click on the SDK link at the bottom. Register, create a login. If you don't hear back, just keep on plugging away till you get one. If you want to take a look at here is their sample app. So this is... The username is Autel SDK on the GitHub repo. Download everything. You're probably getting the gist of what all these sample apps look like. So basically they give you an introduction to all of the different things that you're trying to do. So remote controller, information, fly it, get access to the media with the album. Gimbal is for the camera. Creating a mission with an Evo 2, creating a mission there. Not too sure what RTK is doing here. RTK means the much more precise measurements. So if you're trying to find something to a centimeter, a couple of centimeters, you'd use RTK because typically the drones don't give you that level of fidelity. But the Evo 2 I have doesn't have any RTK capability, so I'm not exactly sure how it all fits in. Here's an example of some interns were working with the Autel SDK, where we were trying to do our cattle counter app. We already had a machine learning model that we could use. So this is basically what we did is we put TensorFlow Lite, trained model onto the phone, and then flew the drone, and then presented the images against the TensorFlow Lite inference engine, and then that shows whether it's a person or a car. The code's up on the Reese repo for GitHub this time, so if you want to try that. Okay, so until recently there was really only the Evo and Evo 2. Now there's a whole suite of Evos, and from the Evo Nano to the Evo 2 Pro. So the Nano is $799 and the Evo 2 is $1795. So quite a spread across there. I don't have a Nano, so I don't know if it works with the SDK, but I'll find out by the time we do the Autel deep dive in a couple of months. Okay, some links for you. So we have pro.autelrobotics.com. We have the link to the Autel SDK, the Android sample app. And then if you want to check out the Autel demo app that we did, we've made that public so people can see that too as well. Not 100% sure if we left the Python scripts for Colab before we did our training, but if somebody wants them, I can definitely find them. Just let me know. Just if you have a problem, just open an issue on our developer account on the Reese GitHub repo, and then I'll make sure that somebody follows up. Okay, so last is Pixhawk. So Pixhawk is basically the flight controller that we're using. But I like this because it's much more of the cross between hardware and software, and there's a lot of open source stuff going on here too as well. So the hardware people really like using this. There's a lot of the blue UASs out there are built on with this kind of technology, and so I thought it was definitely something that I want to include. There's all sorts of Auterion are doing an awful lot in this area too as well with their Sky node. So they're that would be like another manufacturer that's trying to replace DJI. So anyway, but it can be quite confusing because there's a lot going on and it's not really obvious where everything fits in. So when we do the deep dive on this too as well, I'm really looking forward to looking at the all the different flavors, and even in my own head, getting everything figured out between the all the way from rovers, drones, basically not quadcopters, just warehouse robots, all the way up to the VTOL, vertical takeoff and landing. Okay, so the prerequisites are, well, you need to build your own drone in a lot of cases. You could probably, you could go and buy a modal AI, which is already built, and then you need to use Android Studio with Qt. Qt, also known as Qt, is an environment that's owned by BlackBerry, and what that does is a lot of the automotives, such as the Ford Sync. I'm not actually sure if it's the Ford Sync that uses it, but I'm told that 65% of all of the dashboard apps that are built for your car are built with Qt. And it is one of the fastest growing parts of BlackBerry now that their phones have disappeared. But for Pixhawk, we don't really get to use the Qt editor. Basically what we do is we get to edit XML files that are called QML, and then we get to, if we're trying to do anything significant, we end up editing the firmware in C++. So really that's what we are. This is like a lot more low level than what we were doing with the DJI SDK or the Parrot SDK. So the prerequisites, well, we need a drone first. So I took this from Hover Games. So I think they've done it 3 years in a row. NXP has basically sold a kit if you join the Hover Games, which is a challenge for third level students. Basically, it won't be $490, it'll be like, I don't know, $190. But if you don't want to do that, you just want to buy one of your own, you don't have a coupon, it's $500 to get the kit, to put it all together, has all the bits that you need, and then you got to buy the telemetry on top of that. So I think it's a Hollybrook that you're using for the telemetry, and that's another $100 or a couple $100. So when you're done, it looks like this. So it's got all of the things that you need to fly. And it's a great way to learn how drones are put together. Reminds me back in the day of putting together the DJI drones before the Phantoms came out. There are definitely other kits out there, but we've used the Hover Games a few times and it's worked really well. Also, they have on hovergames.com, they have a ton of videos that show you how to put it all together, so it makes it really, really easy. NXP have done a great job. And no doubt they'll have the Hover Games coming up this summer too as well, fingers crossed. So all the Android apps we've looked at have some type of ground control or GCS. So the a lot of what we do at Reese is we build GCSs for different companies. But the NXP and the Pixhawk, they already come with their own GCS. So basically what you're doing is editing a GCS, which is called Q Ground Control or QGC. So this is based on the Qt platform. So the good news is it'll run on Windows, Linux, Android, or iOS. The bad news is that you got to edit the XML files called QML and change it around. You also have to buy a license, a developer license, if you're going to do this seriously. Check it out at if you go to github.com/mavlink/qgroundcontrol. That's the place to start off with. What we did here is we were trying to figure out how to edit how to play around with the QML files. A lot of people, when we've gone to the conferences like AUVSI and Commercial UAV, the hardware people have told us, hey, it'd be great if we had some way of hiding some of the settings, because Q Ground Control gives access to everybody who wants to do it, so that you could change a parameter in a setting on a drone and do some serious damage by making a crash because you don't understand the ramifications of changing whatever parameter you have. So we did a really simple thing just to see if we could hide the settings. So if you go to the URL here, it'll basically walk you through how to set up the environment and then how to change the settings so that you could have like a basic setting and then a factory setting, which we're calling, which we would say like is an admin setting. Let me just, I think I have this. It's going to walk us through what it is. So this is what QGC looks like. Position held. Okay, now I think, where is it? I got to go a little bit faster. So what we're trying to do here is we're trying to expose the settings or hide the settings. So I guess if it's factory, we're unlocking some of the settings, so we're going to have lots more settings. So if we go back again, and then we see our ready to fly, it's got a lot more options than we had before. Okay, so if you go to this URL, it'll show you how to do that. Okay. Define the ecosystem. So there's QGC, which is this queue that we saw here. That's got different flavors too as well. So there's HereLink. We're just doing some work recently with HereLink, which is a version of QGC. So you don't have to have a really crappy remote controller. The HereLink's a great controller. So if you want to add some extra money and use a HereLink with your NXP, that would be the next stage. The NXP would be the cheapest version of a Pixhawk drone, and then you can go up and start buying more expensive stuff. So we're going to use a HereLink here. There's also ArduPilot and PX4, so there are two kind of competing branches of open source software that you might want to look at for this too as well. And then you'll have to start getting into Mavlink too as well, because everything's built on Mavlink. Okay, so Pixhawk, here's a URL. I could have used a bit.ly and make it smaller, but hey, you got it anyway now. But that's where you need to go to buy the drone. Here's where you need to go to download Q Ground Control. Here's our little example of the blog that explains how to set it up. Here's the code, and I put in the Hover Games, which has all the videos for putting this drone together. And then px4.io and ArduPilot if you want to check those out too as well to see what people are doing with the Pixhawks. And then next month, what I'm going to go do is basically go through the tutorials in Kotlin for each of the different tutorials, the FPV, camera, media, all of the ones that I could possibly do with I'm probably going to do it with a Mavic Pro. I think the DJI Mini doesn't have enough going on. So there's probably about a half a dozen examples on the developer.dji.com site that we're going to do. We won't do them in the original Java, so we've converted them all to Kotlin, so I'm going to walk through that as much as I can. Then after that, I think we'll do the DJI OS. Grant Hostica said he's going to do that, so hopefully he'll do that. If not, I'll do it myself. And then after that, we'll look at the Parrot and the Autel, and then get to Pixhawk. If you want to talk about anything that you're doing with drones, I don't have to talk every month. I'd really be very happy if other people want to talk to, so always open to suggestions. Please let me know. Oh, and then we will do one on machine learning fairly shortly after that too as well, because I want to do the parking lot app that we do with the interns to show you how we get to from start to finish, taking our input as images of cars in a parking lot all the way to actually counting cars in a parking lot in real time, and then getting a global count using OpenCV after we stitch the image. Thanks very much. Talk to you next month.